guys, welcome back to my YouTube channel. So my name is Karabo Sitole. So in today's video, I'm just gonna be doing applications, right, of your decomposition analysis. So this question is from the practice tutorial pack that I have. So I'm just going to be applying the content that we learned in one of my videos where I was talking about exponential smoothing and the decomposition analysis. So let's just get right into it. For those of you who are returning subscribers, thank you so much. And to every new person, welcome to the family. I hope you've already subscribed because you're definitely going to love my videos. So let's get right into it. Okay, so I'm just going to be reading. I'll try to provide a copy of the question, maybe make it or send a document along with this video, but I'm just going to be reading in the meantime. So it says the management of a chain of motor vehicles dealership is interested in focusing vehicle sales at their dealership on a quarterly basis, right? So from that very first line, we find that they're interested in focusing sales on a quarterly basis. So we get the information that our P is actually equal to 4, right? Because how many quarters do you have in a year? You have 4 quarters, right? It continues to say that management have sales data starting from the 4th quarter of 2009, right? So meaning that wherever you're starting, you're going to start on the 4th quarter, right, of 2009. So I just rewrote the table so that it's easy to work on it. So you have your quarters, you have your time, your YT, which are your sales, and then your CMAV, detrended data, corrected season, and the deseasonalized data, right? Okay, so they are saying, let's see, you started on the 4th quarter of 2009, and it says that the data and some partial intermediate results are presented in table 1. And they say that all calculations have been rounded to 4 decimal places for all the intermediate calculations. Okay, so this is the figure 1 that they are talking about. So the first question says, which one of the following statements is correct, right? So before we get to that, this is the table that I had. This is the information that was given. What I wrote in pen is what I worked out, which I'm going to explain how I did it. Okay, and I also calculated my detrended data. So let's just analyze the diagram that you give in this whole table. You have quarters. They are starting from 2009. So in bracket, just write 2009, 4th quarter, then it goes to 1st, 2nd, 3rd, 4th, 2010. 1, 2, 3, 4, 2011. 1, 2, 3, 4, 2012, 1. That's where it's ending. Your time, 1, 2, 3, all the way to 14, right? Your YT, these are your sales. Let me just note that down. These are your sales. All the way to time T14, your CMAVs, right? So if you do remember from the content from the video that I made, I said that if your P, right, which can be in quarters, which can be in months, if your P is even, it means that you have to calculate your MAV, your moving average, as well as your CMAV, right? So since my P is even, it is 4, I need to calculate my CMAV. I'm going to show you how you are going to do that, so don't worry. Okay, so you have your sales, you have your CMAV, you have your detrended data, corrected season, deseasonalized data. So remember the steps for our decomposition analysis. The first step is to calculate your estimated trend, right? So to calculate your estimated trend, this is your step 1. You actually, okay, sorry. So this is your step 1. You need to calculate your CMAV or your MAV, depending on whether it's odd or even. If it's odd, you only calculate your MAV. If it's even, just like in this instance, you calculate both your MAV as well as your CMAV. This gives you your trend estimate. Okay, second step, detrend the data. How do you detrend the data? You will take CMAV and subtract it for YT for every time period, right? Okay, that's what you're going to do. So this is step 2. and I wrote the formula that you have to use. So whenever you have to detrend or deseasonalize something, you always take the estimate of that thing and you subtract it from YT. So for example, for the trend, I'm going to take the estimate trend and subtract it from YT. If I want okay, we'll get to the corrected seasonality because I have a table that's going to help you calculate that. But you are always subtracting from YT to detrend to undo something, right? Because that's detrending, to undo the trend, to undo the seasonality, etc. So that's step 2. Step 3 says find the initial seasonality, right? And from there you will correct it. So this is where you correct your seasonality by finding the initial seasonality. So you'll take this detrended data and put it into the table that I told you about. Don't worry about that for now. I'll show you guys how to do it, and then you put it here, right? After that, to deseasonalize, you always take what? You take YT minus your corrected seasonality, and you find your deseasonalized. So this is step 3, and then step 4. After you have found your deseasonalized data, what will you do? You will calculate your regression line and estimate whatever that they need. So remember that the focus will always be whatever you get for whatever answer you get when you substitute into the regression line that you got, plus the seasonality that you got, which you will find from the corrected seasonality. Okay, let's get right into the questions now. Now that I've explained the figure, I hope when you get to that test and you're given a diagram like this, you're able to like analyze and extract the information that you need. Okay, so the first question says, oh, another thing is that we are given a graph, right? So please forgive the fact that what I'm about to oh my god. Okay, electricity, just a minute. Okay, one of the disadvantages of living in South Africa is that there's load shedding. So I was saying that please forgive the fact that the electricity just decided to like go. Yeah, okay, cool. So I was saying please forgive the fact that what I'm showing. Okay, sorry about the lighting. I need to turn it on. Okay, that looks better. Okay, so I was saying please forgive the fact that what I'm showing here has a lot of writings. Okay, cool. So this is the data I was talking about, what I wrote down, right? So another thing is you're also given this thing, this diagram right here, right? So okay, I'm not sure if I should. Okay, I shouldn't. Okay, so when you're given this graph, what you need to check is your amplitude, right? And check whether there's seasonality, right? And checks, okay, you will check the amplitude to know if you need to use the additive method of your decomposition or the multiplicative method, right? So let's check our amplitude, right? So what you will do is you will join the endpoints, right? So you'll start, these are the endpoints, so you'll start from here, join to this endpoint, another line to this endpoint, another line to this endpoint, and then go down, join the endpoints. If you guys see, it seems like there's a pole created, right? There's a pole created, so that's telling me that your amplitude is constant. If it was not constant, it was going to be something like this. Then you know it's increasing, something like this, right? It's not following a straight line. It's kind of like increasing, or it could be decreasing, whatever you are given. So for the fact that it's falling within a pole, right, it's telling you that it's constant. Your amplitude is constant, hence you have an additive method being used, right? If you see something like this, it means they are using a multiplicative method, right? Okay, cool. Okay, another thing, people have been like asking me, how do you see whether you need to use the additive or the multiplicative, which I just explained. Another thing that another question that I've been getting a lot is how do you see the trend, right? Okay, so look at this data on an overall basis. Does it seem to be increasing or does it seem to be constant? The points do not need to perfectly align. On an overall basis, do you see the graph as tending to increase, or do you see the graph as tending to be constant? in this case on an overall basis, without me focusing on any random fluctuations, without me focusing on anything that's trying to confuse me, does it seem like the graph is increasing or decreasing? For me, it seems like on an overall basis, the graph seems to be constant, right? There's a constant trend. It's not increasing. The graph is not increasing on an overall basis. Neither is it decreasing on an overall basis. It just seems to be constant. So my trend will be constant in this case. Okay, so the first question says, which one of the following statements is correct? So an additive model is not appropriate since the amplitude of the series is constant. This is false because we just proved that this amplitude is constant, and when it is constant, you need to use the additive model. B, Winter's model is appropriate since the amplitude is constant. The amplitude is going to tell us whether you need to use your additive or multiplicative. ESCOM. Okay, a lot is going on here, so I'll make sure. Anyways, C, a multiplicative model is appropriate since the amplitude of the series is constant, right? That's false because a multiplicative model is used when the amplitude is either increasing or decreasing. Remember what I showed you here, when you have something like this, that's when you use the multiplicative model. Okay, and then it says an additive model is appropriate since the amplitude of the series is constant. That is true. We said you use the additive model when the amplitude is constant, right? And how do you see that it's constant? Remember, you draw a line on your endpoints and you see if it's creating something like a pole. Okay, cool. So the correct answer is D. Let's see why E is false. A multiplicative model is not appropriate since there is seasonality in the data. We already established that the previous one is true. So false. Okay, let's go to 1.2. I hope this electricity doesn't decide to go again. The value of X in the table is, right? Let me just erase. The value of X, this is the value of X. This is what we're looking for. CMAV of time period 8. Okay, so whenever you have to calculate a value, a CMAV value, right? Okay, whenever I have to calculate a CMAV value, what I want you to do is see where it is, right? Okay, so this is where it is. Here, this is where it is. This is where it is. I want you to draw a line like this. This is what I do normally. Okay, after you've done that, count 2 steps upward, right? 1, 2, draw a line. Okay, draw a line, draw another line. Go back to the one you're focusing on, which is the middle line, right? Count 2 steps downward. 1, 2, and draw a line. Okay, so this is the rectangle that you are going to be working with. Look at your sales figures. And I want you to count four. I want you to take 4 steps, right? 1, 2, 3, 4. Draw a rectangle under that. I want you to skip the first one and draw another rectangle starting from there and take 4 steps again. 1, 2, 3, 4. Do you guys see what I did? Remember, highlight the one you have to work with. Go 2 steps upwards, right? Okay. Draw a line. Go 2 steps downwards, draw a line. And then I want you to like make a rectangle. Count 4 values from like the beginning, right? 1, 2, 3, 4. Okay. Make a rectangle. Remember your starting point was 136, right? Okay. Now you need to go to the next point, and that's where you're gonna start your new triangle, right? And a bigger one. Okay. Next one, right? Another bigger triangle. Count 4 values. 1, 2, 3, 4. Cool. There you are. After you've done that, this is gonna help you to calculate your MAV, then your CMAV, right? Okay, so I'm just gonna have to like, okay, I need to make sure that you guys can actually see. I hope you can see. Okay, let me just make sure you guys can see. I'm sorry for the noise. I'm so sorry. Okay, cool. Okay, Okay, I also need to make sure you see that the graph, I mean the table. Okay, I hope you guys can see. Try my best. Okay, so what you're going to do is to calculate first your MAV, right? Remember, there are two steps. If it's odd, you only calculate the MAV. If it's even, you calculate the MAV, then your CMAV. It's even in this case. So I'm going to calculate my MAV, then my CMAV. Cool. Is it even recording? Oh, it is. I'm sorry. Okay. Okay, so remember the first triangle that you made? That's your MAV1, right? So you're going to add all the values and you're going to divide by how many they are. So they are 1, 2, 3, 4. So you add all the values in the first triangle and divide by 4. You get 134,5 divided by 4. Sorry. You add all these values and divide by 4, and this is the answer that you get, okay? Remember the second triangle that you made? This bigger one? That's your MAV2. So you will add all the values in the bigger triangle and you'll divide by what? By 4, right? And you'll get 133,75. So your CMAV is this plus this divided by 2. So you will take 134,5 plus 133,75 and you divide by 2 and you get 134,125. So that's your X value. Hope you guys understand. This is very important. If you didn't understand, pause the video and like replay it again. If you have any questions or you need clarity, comment in the comment section below and I'll get back to you guys. Cool. So now I've calculated my X value, which was the question for 1.2, right? Okay. So it's this 134,125 and I wrote it in pen. Okay. So the next question says the corrected seasonal estimates for the fourth quarter. Okay, the corrected seasonal estimate for the fourth quarter is, okay, using the method of means, and rounding intermediate calculations to 4 decimal places. If you guys notice, they didn't tell us the period. They didn't tell us which is the fourth quarter of 2009 or the fourth quarter of 2012. This is something you will see why as I do the table, right? Okay, let's get to it. Okay, from now on, from here onwards, I'm going to start drawing to answer the questions. Okay, so what I want you to do is the more you practice, the more you'll know how to draw the table, right? Okay, so what I want you to do is draw this table to help you. Okay, I'm not sure how many quarters they are, so I just need to check that. So remember, I'm looking for the corrected seasonal estimates. I haven't calculated it on the other other data. So what I need you to do is to go to your detrended data. I hope you guys can see this. I need you to go to your detrend data, right, and see where the first number is starting in terms of quarters. So it's starting at quarter 2. Okay, starting at quarter 2, our quarters end at quarter 4. So I want you to write 2, 3, 4, right? So you'll need 3. Okay, you'll need 3. Oh my god. Okay, you know what? I'll squeeze everything in. Okay, so you're going to need 2. I want you to write it in that order. It said 2, 3, 4. Excuse me. For those who didn't see, you go to the first value of your detrended data and you see where the quarter is starting at 2. So 2, 3, 4. That's where your quarters are ending. So I want you to write it in that order: 2, 3, and 4. Right? Okay. So these are your quarters. These are your quarters. Okay. And then I want you to leave spaces in between. And then I want you to write, okay, before I write, I want you to go back to the question. What did the question say? Using the method of means, right? So you will write means here. You write means. If they say it, use the method of medians, you write medians. Okay. Okay, let's just extend our table. And then I'm trying to take my time with this so that you guys understand. I'm sorry that the video is going to be long. I want you to write correction. And I want you to write corrected. Right? Okay. Now, what I want you to do is to take your detrended data and insert it here according to quarters. So you go to your table, which was given to you, and let me use my ruler. You write your detrended data, right? So you'll have negative 11 for the second quarter. 11, right? So I want you to go to every second quarter. Okay, the first quarter, the second quarter that we had as the first value is negative 11. So I want you to go to another second quarter. You have negative 11,625. Negative 11,625. I want you to go to the next second quarter. Right? Negative 9,625. I'm here. Negative 9,625. Right? I want you to go to the next quarter. Next second quarter that you have. You have no any other second quarter. So that's where you end. Now I want you to go to the third quarter. Remember, this is the next one. So third quarter. Go to the first third quarter. This is the amount you have on your detrended data. Write it down. 1,125. Go to the next third quarter. Okay. Go to the next third quarter. You have 0,875. You write it down. 0,875. Can you guys even see? Okay, I hope you can. Okay. Go to the next third quarter. Remember we're at 0,875. Go to the next third quarter. Negative 0,5. Remember, I'm looking at the detrended data, right? And I'm just writing it down into the table. Now I want you to go to the fourth quarter. First fourth quarter of your detrended data is 10,375. Okay. 10,375. I want you to do the same thing. Next fourth quarter. Next value of the fourth quarter is 10. Next value of the fourth quarter is unknown, right? Z dash. Okay. Now that you've done this is very important, and like it's a process kind of thing where you have different steps of what you need to do. So it's very important for you guys to understand. So what I want you to do is to go back to the question. Ask yourself, what method did they say I should use? They said I should use the method of means. What does it mean? The sum of my terms divided by how many the terms are, right? We did means and medians in chapter 1 where we're looking at our descriptive stats, right? So whenever they say method of means, don't get confused. It's the same mean that you know. When they say method of medians, don't get confused. It's the same median that you know. Okay, they said method of means. So what am I going to do? I'm going to add my values for each quarters, and I'm going to divide by how many they are. So let's do that. Negative 11 minus 11.6. Okay, I don't like using this calculator. Oh, I'm going to need to store my data. 11,625 plus, negative 9.625. And then you'll divide by 3. You get negative 10,75. You do the same for this one. 1.125 plus 0.875 minus 0.5. 1.5. Do the same for the fourth quarter. Negative, oh my god, okay, wait up. Minus 11.625 minus 9.625. Okay, I did right. On this one, 1.125 plus 0.875 minus 0.5. Okay, yeah. On this one, I was supposed to divide by 3. Divide by 3, 0.5. Right? And then you do the same for here. 10.375 plus 10. There are only 2 values, so I'm only going to divide by 2. 10,189. Right? The next step, okay, I'm going to have to make sure that you guys can see what I'm doing. I hope you guys can see. Honestly, I'm putting so much effort into this video. Okay, so the next thing that I want you to do is like create a small Nyana table where you write your totals. You will add these, right? So you already have 10,189, so plus 0.5 minus 10.75. you get a negative 0.061. Okay, I hope I haven't made any mistakes in the process, but yeah, the process stays the same even if I make numerical errors. This is what you get, right? So the main aim is to make this 0. So if you have a negative 0.061 and you want to make it 0, that means you need to add 0.061, right, to all these values, right, but a portion of it. So you're going to multiply this by -1 to make it positive, divide by how many there are so that you can add it equally, 1, 2, 3, right? So you divide by 3. Okay, and this is the value that you get. So the correction is plus 0.0203. Remember, they said round off every intermediate thing to 4 decimal places. I hope I haven't made mistakes. I have a gut feeling that I made a mistake in this calculation. But anyways, we'll see. Plus 0.0203, right? Okay. And then after you've done that, the corrected one is where you are saying minus 10.71 plus 0.2, right? Okay. Okay, focus. I was trying to see if I've made any errors. So this is the answer I had, right? So I'm just going to store, shift, store. So I have a negative 10.75 plus whatever I stored is A, and you have negative 10.72. See, I knew I made a mistake somewhere. Okay, you guys. Okay, let me see something. If really I have made a mistake, and I should not get what I'm getting. 10.2. Yeah, I made a mistake somewhere, and I'm not sure where that mistake was. Okay, let me pause the video. I'll come back. Sorry for the noise. Okay, so I saw my mistake. So remember, we have 4 quarters. I'm just writing them in a different way. So it was 2, 3, 4, but I forgot about 1. So you do the same thing. You go to your degenerate data. The first one is okay, here's the first one, 1.25. So I'm just going to write them quickly. So you will have 1.25, right? You go to the next first quarter, you get negative 1.25. Okay, sorry, so sorry about that. So the mistake was here. I don't know what I did, but it's 10.1875, right? Okay, your ones don't make a difference because they're just gonna cancel. You add everything. Okay, let's just redo that. I'm so sorry that the video is this long. Minus 10.75. Okay, this is what you get. The total is negative 0.625. So you take this, you times -1 to make it positive, then you divide by let me see. Okay, you divide by 4 because there are 4 values. Okay, so it's plus 0.015625 plus 0.015625 plus 0.015625. And then the corrected one is this, right? Okay, so for the second quarter, it's going to be negative 10.7344. For the third quarter, it's going to be 0.515625. For the fourth quarter, it's going to be, let me just pull this answer. Okay, I'm trying to rush things because time has like, we don't have time. 10.1875 plus for a, yep, there we are. My heart, the way it becomes happy when I see the value I calculated in the multiple choice. Guys don't understand. So the answer is D. So that's how you find the corrected seasonal. So I remember I said that they didn't tell us like the year. It's because remember that we are grouping the data. So for the second quarter, for every second quarter, regardless of the time, you are going to have the same value. For the third quarter, the corrected season for the third quarter is going to be the same value, same as the fourth quarter, same as the first quarter. Okay. Yeah, so this is going to be plus 0.015625. That's your corrected season. Okay, so 1.4. Can you guys see? Where's my pencil? Okay, where's the pencil? Somewhere here, so that I know that you guys can see, but it's gone. So they are saying if T is equal to 132.2 plus 0.28, what is the forecasted sale in the third quarter of 2015 to one decimal place? Okay, so they are talking about 2015, right? So what you have to do is just like, you know, write it down all the way down until you get to 2015. Okay, so I did that here, but you guys are probably not going to be able to see. 1 2 3 4 2013, 2014, 2015. So I'm at 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. I'm at T25, right? Okay. T is equal to 25. So I'm use the regression formula that I'm given. T25 is equal to 132.2 plus 0.28 times 25 is equal to 132.2 plus 0.28 times 25. Okay, you get 139.2, but that's not the forecast. The forecast is always whatever you get plus the seasonality of that. So it's 139.2 plus the seasonality. So what you would have to do is to calculate, okay, they said the third quarter, right? So what you have to do is to calculate where does the seasonality fall under, right? So third quarter. Okay, just a minute, guys. Okay, so I'm making quite a lot of silly mistakes. It's probably because I'm rushing things. Okay, so sorry about that. I just made a silly mistake. So remember they said the third quarter, but I took the fourth quarter, which is T25, but the third quarter is T24. So all you have to do is to like say one, go all the way down, write your years, and then get to 2015, third quarter, and then count how many they are, 14, 15, all the way down. You get that is 24, right? So I was supposed to substitute T24 instead of T25. Okay, so when you do that, yeah, you substitute into the formula. It says 132.2 plus 0.28. This is what you get. After that, you need to add your seasonality. So remember they said the third quarter, so it doesn't matter where it is. This corrected season value is going to be the same, right? So another thing here, I needed to add plus 0.5. Silly mistake there again. So I just fixed it here. So this is the season for the third quarter, right? And then the answer you get is 134.435.625, rounded to one decimal place, 134.4, and then you are done. So that's how you do it. Thank you so much for watching the video, and I'm sorry once again, Wuti, it's long, and I'm sorry that load shedding decided that it's gonna, you know, hit us while we are doing the video. So thank you so much for watching. Please comment, like, and subscribe. Share also so that it helps somebody else. Okay, bye.